In this video, we are going to see about computer networks, and in that network layer protocol IPv4 classless addressing. These are few references. IPv4 is a network layer protocol, as we said. IPv4 expansion is Internet Protocol version 4, and it is one of the core network layer protocol, and this is the first version that was successfully deployed, and it defines and enables the internetworking at the network layer. And it is a connectionless protocol. It does not guarantee the delivery, so it try at its best. It is called as best effort delivery protocol, and its main function includes IP addressing. So we shall see how IP addressing is done. The two major categories of IP addressing is classful addressing and classless IP addressing. Classful addressing is having address scarcity issues. So we are going with classless IP addressing, which is actually derived from classful addressing. CIDR is used for classless IP. So in classless addressing, an address will not define the block. Okay, for example, so if I take one address 190.8.24.58, this can belong to many blocks based upon the mask what we are using. So if I use the mask /16, so it is coming under a block that has 16 bits as net ID portion. If I use /20, so that will become a part of another block. If I use /26, it becomes a part of different block. /31 means again a different block. So mask defines the block, okay, not the address. And mask is not fixed as like classful addressing. In classful addressing, /8, /16 and /24, these three are the possible masks, but here we can have any value here. Okay, now the slash notation is not fixed. Okay, so the prefix length is not fixed. So from that, how we can extract information and how the mask value is used to derive various useful information, and in this how we can get the network address and how is it helpful, how we can do block allocation based on this slash information, okay, with a given IP address block, and how do we plan subnetting, and how do we design subnet, like what is the mask for each subnet, first address, last address, all these things we are going to see. And how do we find information about each subnet, and how we can do address aggregation, and what are all special addresses which are reserved as special IP addresses. These are the things we are going to cover. Now, a single block of class C can be divided into sub blocks. So that concept is called as subnetting. Okay. So now in an IP address hierarchy, already we had net ID portion and host ID portion. Now we are going to have subnet ID portion. So together I can call this as net ID portion. Okay. So to identify number of subnet bits, okay, this as per the number of IP addresses required. Now we will be using the calculation like this. So now if I take number of addresses required in a subnet is capital N. So now N will be 2 power 32 minus N. So now this small n is the original slash notation, that is the prefix length, mask size, or net ID bits, subnet ID bits. So in that way we can understand. Okay. So I can rewrite this equation like this. N equal to 32 minus log n to the base 2. So if I want to know number of addresses required in a subnet, then I can use this formula. And if I have to know, I know how many number of addresses required for a subnet, but I don't know what is the number of bits in slash notation that are to be added. So in that case, I can use this formula. So now we shall see one sample for that, how it can be done. So this is the given IP address 17.12.14.0/26. So with this, I should create two subnets. So how we are going to calculate the subnet mask bit? So now I just have to calculate the size of the block. So how do we calculate the size of the block? 32 minus the mask bit, remaining 6. So I can have 2 power 6 combinations. So 64 addresses are there in this block. So I can have two subnets. The main constraint for making a subnet is it should be in powers of 2. So I can have 2 into 32 or 4 into 16 or 8 into 8. So in that way I can have subnets. Okay. So now, so if I am interested in creating two subnets, each with 32 addresses. So totally 64 are there. So 2 into 32 I can create two subnets. So if that is my idea, then how do I identify the subnet mask for each subnet blocks? Then, so I am taking number of addresses in each block is 32. Now I should know what is the subnet mask bit. So I am applying this formula 32 minus log 32 to the base 2. So 32 can be written like this 2 power 5. So now log 2 power 5 to the base 2, the result is 5. Okay. So the whole calculation becomes 32 minus 5. Then it is 27. So the subnet mask for the new subnet, okay, that will be 27. So here the original block is having subnet mask as 26. The divided subnet will have 27. So in that way we can calculate the mask value for the new blocks, divided blocks, subnetted blocks. Okay. So hence the subnets would be 17.12.14.0/27. Another subnet would be after 32 addresses, 0 to 31. So next is 32. 17.12.14.32/27. So these two are the subnets, starting address of the subnets. So in that way we can calculate it. Next, the rules for subnetting, as I told, the number of addresses should be in powers of 2. I cannot allocate 30 addresses. I cannot allocate 25 addresses. It should be in powers of 2. And prefix length to be calculated using this formula as we did. And starting address should be divisible by number of addresses in that subnetwork. And moreover, if we assign addresses to the larger subblock first, then automatically the starting address is divisible by number of addresses. So if I want to create one block, one subnet with 32 addresses and another subnet with 16 addresses and two more subnets with 88 addresses. 4 subblocks I wanted to create in the previous example. Then first I should allocate the 32 size. Next 16 size, next 8 size, another 8. So in that way if we plan, then automatically the starting address is divisible by the number of addresses. So that is the clue here we should use. Now, so this is a sample. A block of addresses is granted to a small business that needs 15 addresses. One of the addresses 205.16.37.39/28. So now we have to identify the size of the block, first address in the block and last address in the block. Now the restrictions we should remember: addresses should be allocated contiguous and number of addresses should be a power of 2 and first address should be divisible by n. So if this is to be satisfied, the clue here is larger subblock should be assigned first. Okay, so that we have to remember. So one of the addresses is this, means we can easily calculate size of the block, first address and last address. So how do we calculate that? Now, to find the number of addresses, we have to use the formula 2 power 32 minus n. N is the subnet mask bits. So now, for our case, 28. So I am using 2 power 32 minus 28. 2 power 32 minus 28. So that gives 2 power 4 and the result is 16. So 16 addresses are there in this block. And this is one of the addresses. So this may be a starting address or last address or in between address. So now we shall check which is the first address in this block. So to find first address, we have to make the rightmost 32 minus n bits, that is host ID part. All these are to be made as zeros. So now the given address is this and this is n value. 32 minus n, okay, becomes 4. So last 4, rightmost 4 bits, we should make all zeros. So that will give us the original first address, original IP address, that is the starting address of this block. So I made these 4 bits into zeros, all zeros. So only this bit is there. This is 1, 2, 4, 8 and 16. So one bit is missing here. One more 0 should come. Okay. So now here is 1 and this should be 0. Okay. So in that way, it is to be calculated. Okay. So the result is 32. Now to find the last address. Last address in the block can be found by setting rightmost 32 minus n